Hello everyone, welcome to Zaref Game Dev, and in this video we are going to create the Tricky Disc game in Unity. So it's another one simple hyper casual game, and I got this idea from another YouTuber. I don't know if it's a channel or a studio, and I think its name was Shapeshift Studio. So he creates game in another software, uh, mostly for iPhone, and the game ideas have been like inspired from, not inspired. I've directly just tried to create the mechanics what he had done, and we'll be just creating the basic template for the game. So if you want to see how the game looks, you can directly check it at the end of the video, and we'll start creating the game. So here I have opened up an empty Unity project, and I've created a couple of folders, and inside the scripts there's just this GameManager script. Now first let's create a new scene, and we'll call this scene as the main menu, and we'll delete our sample scene, and we'll create one more scene which is going to be our gameplay scene. So these are just going to be the two scenes inside our game. And after that, let's import all of our resources and the color palette which I had created before. And I just added a couple of colors, so I'll add it to the editor. And to see the color palette, let's change it to colors project, and you should be able to get all of the colors when you click on the color. You won't be able to see it. It doesn't capture the external window. So these were the colors. Now let's import all of the resources. So for the resources, we have the fonts, the sprites, and our mm, audio, and this three will be our resources. Now let me bring those resources inside our resources folder. So these are all the just the basic images. This is the update image, which is when we like hit the uh, point. This is going to be the default click image, and this are just the basic audio, and this is going to be our font which we are going to be using. Now let's first create our font first. So we'll go inside our font asset creator, and we'll select our font, and where there is not going to be anything else, and we'll do generate font alias and directly save as. So it will create a new font for us. We don't need to change anything else, and this is going to be our default font. And after we have created this font, let's import mm, what needs to be imported now, the pixel and the circle. So I think I left it out, so let me get it. So it was inside my notes and tricky disk. So there is just going to be this one pixel image which we are going to use, and it's going to be need to be pixel perfect, and let's make it full right 1 pixels per unit, and let's have it as a point. So whenever you want to create an empty image which is just going to be a default square, we'll use our current uh, pixel, and let's remove all of our packages. So JetBrains is not going to be needed. VS Code editor, similarly it's not going to be needed. And visual scripting, it takes like too much memory space. So as you can see, whenever we save the project, it will compile it. So at the start of the project, it's good to remove all of the packages which you won't need. So version control is also not needed if you are creating any commercial project or not using the default, the plastic SCM. You can remove the version control. And test framework also, if it's just a simple hyper casual, test framework will also won't be needed. And text mesh pro, which we have imported, it's going to uh, need. And timeline is also going to be needed. It added all the animation curves and so, and also the basic UI editor. And let's update our Visual Studio editor. So these are just the default packages which we are going to need. So if we are creating a build for Android or so if we go inside our build settings and if we change it to Android, and I don't think it will add any of the packages, so the final build size will be lower. So if you use like visual scripting or the test framework, it will like add it as a library. So this is just the default way I get to work around that. So mostly if there is not much uh, resources in your game, it would be around like 10 to 15 megabytes instead of going to 40 to 50 megabytes. So let's first fix up our camera. The only thing we are now going to need to change is the color, which is going to be our default bluish black. Let's change the aspect ratio to, uh, I think, yeah, I changed the project. Let's change it back to our Windows because I have my reference resolutions in there. And let's first set up our camera. So our main menu manager is going to be pretty simple. So here I have iPhone, we are going to use the iPhone resolution and it's going to look like this. Now let's create our two managers, which are going to be our main menu manager and our audio manager. Now inside our camera, let's first add our title, which is going to be a text. So we'll call it title text, and our title text is just going to say Ricky disk, and you won't be able to see it clearly right now. So let's not have it bold. Let's change the font to our SVD. Let's increase the size to 160, have it scale centered, and we'll change its color to our blue color, and we'll change its height to be 256. So as you can see, it looks a little bit better right now. And all the resources which I have used, they are like there was no need for any references. Somewhere from Kenny's, and a couple of few the sounds were from some of the pack which had CC0 license, so you can use it wherever you want. And now let's change our error, so which is getting caused for the text mesh pro. So let's go inside our project settings, and if you get this error, which is just going to be because our default font does not have like the fallback for all of the different settings. So if we go inside text mesh pro and settings, we'll disable the warnings, so it should be done. Where is our warnings? And now it won't show anymore. And let's close all of the tabs which are not needed: build settings, project manager, and asset store. So this is our default. Where is, okay, so this is going to be our default screen, and we'll start creating our text. So it's just going to be simple, there is nothing much. So first is our title, which is going to be positioned as 640, and after that anything else, 96 centered, and Let's add size to be 96. 128. What is this? Right now, 128. Okay, so this is going to be our title. We can have it like more, and it's going to be positioned at 640. And let's add a little bit more size to it, 128. Now after that we are going to have an image, so let's just add an image, and it's going to be a title image. For the sprite, let's just go for our sprites and we'll add our circle sprite. So let's just type circle. You can also like have some other sprite, but for now I'm just going to use the circle, and it's going to be a white, but having low transparency. It's just going to be the most backside of our disk, and its size is going to be 256 by 256. Now after that we'll position at 640 minus 128 minus 128. So this is going to be, yeah, 384. So this is going to be our title image. Now let's add two more images, which is going to be 128, and this one, it's going to be the black color, and our sprite similarly, it's going to be our circle, and we'll duplicate this image, and you can call it whatever you like, and its size will change it to 64 by 64, which is the centermost, and we'll turn it blue so it looks coherent. And after that, what we need are just three buttons. So let's create our first button, which is going to be an image, and we'll call this play button, and its size is going to be 512 by 128, and its position, it's going to be 380. Let's position it at 0 first, and for the sprite we are going to use our 9 slice sprite. So now for this button, we'll set its color to be our default blue, and we'll duplicate this button two more times. And the second one, it's going to be for our sound, and it's going to be at negative 192. And our final one, which is going to be at negative 384, it's going to be for our quit. Now, yeah, we need to set at screen space camera at the main camera, so it doesn't look good enough right now. And instead of constant pixel size, we'll set it to scale with screen size, which is going to be our 1170 by 2535. So now it looks better, and we are going to match the height. So these are going to be our three buttons, and similarly we'll add a button component to our all three of them, and transition, it's going to be now. Now inside our play, what we'll do is we'll add a text, and let's just call it text, and all it's going to do is say play. Let's position to the center, have it get across the whole screen. Let's make the size to 128, change the font to HVD, and I think it doesn't needs to be at the center. Let's have it at the top, and we'll need to resize all three of our. So let's add 128, and for the height let's have it as 160. So now it looks better, and for our play it's going to be at 0, but negative 32, negative 32, negative 256, and let's position it at negative 512. So You can change it however you like. So this is going to be our default size. And for our play text, let's change it to have it. Hmm, yeah, let's have it there only. Now let's just duplicate this text, parent it to quit, position it at 0, and we'll just call it quit. And I think -512, -256, 0, -256, -512, bottom 0. So this is going to be our quit, and let's rename this to text. And inside our sound we are going to add an image, which you can call it however you like, and it's going to be 128 by 128. And for the image we are going to use our default sound on first, so it's still to 4, so 160 by 160. So this is going to be our default main menu. Let's add our scripts for our main menu. So inside our scripts we'll create the main menu manager script and our audio manager script. Now the functions we are going to need is just the play and the quit button. So let me sign in. How much time is it? 16 minutes. So let's just create it fast. There's nothing much, and let's rename everything so it doesn't look bad. So play, text, sound, and image. And inside our audio manager we'll attach a audio manager script and an audio source component, and it's not going to have loop and play on awake. And let's decrease its volume to 0.5. Our main menu manager is going to have a main menu manager script. And now let's start scripting. So let's go inside Visual Studio, and first we'll code our main menu manager. It's going to be pretty simple. So let's delete everything. We'll need to go in the main menu manager first. And yeah, we are inside the main menu manager, and now let's create a couple of variables first. So first we'll need using unity engine.ui for the image and collections, and we'll see how we are going to need, and we'll also need using unity engine.scene management. And let's do a serialized field, and first one going to be a private image, sound image, and serialized field private sprite, and it's going to be for the active sound sprite and the inactive sound sprite. And no more. So inside our start, let's set up our sound first. So our sound is going to be, so if it is equal to 1, so if it is active. Now what is equal to 1? So we'll get player prefs dot hash key, and we'll need to add our constant script. So I'll create a new script which is going to store all of the constants, and copy paste all of our constants inside that script. So I'll need to get it, yeah, I'll need to get it from my assets. So inside my scripts and my constants, open with notepad AC, and finally I think it will have the constants. Let's open up the constants, and These are going to be the constant script, which is going to just have the tags and the default string names. So what we are going to check if it has the key for constants.data dot setting sound. So if it has it, then we'll get it. So player prefs dot get int constants dot data dot setting sound. Else what we are going to do is by default we'll set it as 1. And after that we need to set the sound image. So sound image dot sprite is equals to, if the sound is active, then we'll use our active image sprite, else we'll use our inactive sound sprite. So this will automatically set it up. And after that we'll use AudioManager dot instance dot add button sound. So it will add sound to all of the buttons, which will create it afterwards. Now let's add all of our functions. So first one is going to be the click the play, and it's just going to do scene manager dot load scene constants dot data dot gameplay scene, which we have renamed as gameplay. Then public void click quit. Now inside our click quit, we'll just call application.quit, but for testing purposes inside our Unity editor. So we'll check if we are inside our Unity editor, then we'll call Unity editor dot editor application dot is playing, and we'll set it to false, and we'll end the if, so it will automatically get updated. And finally, which is going to be our public void toggle sound, what we are going to do is we'll get this sound, and after that we'll change the sound to not sound, and we'll update our sound image sprite, and we need to call the audio manager dot instance dot toggle sound. So both of them we are going to need to create it, and here we just get the sound, we also need to update it. So we'll do player prefs dot set int constants dot data dot setting sound, and we will update if our sound is on, then we'll set it to 1, else we'll set it to 0. So this is just the main menu manager. We don't need the collections and collections dot generic. And next thing we are going to do is have the functionality for it inside the audio manager. Now let's create the public static audio manager instance, and which is going to be get and private set, and inside our awake we'll set the instance to this. Now our audio manager is going to have the audio source component reference, so it's going to be a serialized field audio source, and we'll call it effect source. And after that we'll also have a serialized field private audio clip, and it's going to be click sound, and private bool for is sound muted, and finally private bool for is sound muted, which is going to have a getter and a setter. Now inside our getter, we'll call is sound muted is equals to player prefs dot ASCII constants dot data dot setting sound. Then we'll get it as player prefs dot get int constants dot data dot setting sound, and else what we need to do is else we'll set it to 1. So this is the value, and our mute is going to be if it is equal to 0, and we'll return is sound muted. And similarly inside we'll set the value, and we'll set player prefs dot setInt constants dot data dot setting sound, and if our sound is muted then we'll set to 0. If it is not muted then it's going to be 1. And yeah, that should be it. And we also need to check if instance is equals to null, then instance is equals to this, and don't destroy unload our game object. Else what we are going to do is destroy our game object and will return. And inside our awake we'll set our player prefs dot setInt constants dot data dot setting sound. We'll set it to capital is sound muted, then 0, else we'll set it to 1. So it will automatically set up our sound, and our effect source dot mute is going to be is sound muted. So this is going to be inside our awake function, and after that we are just going to have two more functions, a couple more. So first one is the add button sound, and here let's first get our buttons is equals to get components of type, find objects of type, and we are going to have the type of button. For that we'll need to use unity engine.ui, and we need to set button here, and pass one more parameter which is going to be true, so it will also get our inactive objects. And for less than button dot length, so instead of buttons we'll call it button. What we are going to do is buttons of I dot on click dot add listener, and we'll create a lambda function, and what it's just going to do is effect source dot play, and we are going to play sound, pass our click sound, and we'll need to create this function, so which is going to be public void play sound, and here we need to get an audio clip as a parameter, and you can just call it whatever you like. We'll just call it clip, and PLAYSOUND, not effect source dot play sound, just play sound. And here inside our play sound we'll just call effect source dot play one shot, and we'll pass the clip, and finally it's going to be our public void toggle sound. So the toggle sound will just check effect source dot mute, and it's going to be is sound muted. So if a sound muted is true, then it will be muted. Now there should be no reference errors in our main menu manager. Our constants is also set up. Now let's go inside Unity and let's add all the references. So first for the audio manager, we'll need the effect source and our click sound, which we have inside our resources. And for now it doesn't have any audio clip, doesn't matter. And inside our main menu manager, we are going to need the sound image, which is our image parented to the sound button, and our two active sound button and our inactive sound button. Now let's hit play and let's see if our sound is on and there are not any errors. So we can hear all of the sound, and currently the buttons we need to also add the functionality. So first add our functionality to our play, and it's going to get from the main menu manager script and it's going to be click the play. Similarly for the quit, which is again we'll get it from the main menu manager, which is going to be click the quit, and our image, which is going to have the function for our click the sound or toggle sound. Now for the scene manager to work, we need to add the current active scene, and we also need to add our gameplay scene to the build. So let's go inside gameplay. Okay, there's a problem. Let's first add it and after we'll see how we are going to fix it. So this is going to be our main menu manager and our gameplay scene. So let's go inside gameplay and we can just directly yeah, we'll just directly cut and we'll paste it inside our main menu scene. So let's hit paste. Where did it go? Okay, so I think we'll need to change our gameplay to main menu. We can't change it. Let's rename our gameplay to game. And so this is our main menu and this is our gameplay. Now this is going to be our main menu. Let's have all the errors afterwards. So this is our main menu and this is our gameplay. Now inside our build settings, main menu should be first, doesn't matter. But let's hit play and we'll check if our quit is working. We already heard the button sound and uh, I press it second time. You can't hear the sound. So we are toggling the sound, but we can hear the sound only once. So if we hit play, as you can see, the level was loaded and the sound did not the sound was not uh, playing, so because we muted it. Now this is going to be our main menu scene. Now let's start creating our gameplay scene. So our gameplay scene is also going to be somewhat easier as it's just a simple hyper casual game. And inside our gameplay scene, the scripts, there is just going to be the game manager obstacle and the player script. Yeah, just three more scripts and a couple of prefabs. So let's start creating for our gameplay. So we have the gameplay scene opened up, and first thing we'll do is we'll set up our color and the camera size. It's going to be 11.7, which is our width of the screen. And after that, 21448, what was the color? Yeah, let's set it to black. 216, 218, 4614. Yeah, this one's the color. Now, after we have our main camera, why there's the problem? I don't know. It was, doesn't matter. So the first thing we'll create is our UI. It's going to be simple and there's not going to be much. So let's first create a text. We'll call it score, and our score is going to be at from the top negative 256. Its size is going to be 512 by 512, and let's change its text to show some value, and its size is going to be 256. The font is going to be our font which we have already used, and position to the center. So this is our score. Let's increase the character gap to 15 or maybe around 10, and that should be fine. And our score color, it's yeah, white is fine, and that's only going to be shown inside our main gameplay scene. Now let's create an empty, and we'll call it end panel, which is going to have an image component attached stretched to the whole screen, which is going to be a pixel, and it's going to have a color of our black. Now inside our end panel, again we are going to have a score, which is going to be our end score, and our end score is going to position at 0, 5 and 2, and its size is going to be 5 and 2 by 5 and 2. Size, let's set it to 128. Our font is going to be default what we used, position to the center, and the text is just going to call 12 or whatever it is. 256 plus hmm okay, textual and size was 384, so everything else is fine. And its color, we are going to use our green color, and position and size are perfect. Now beneath this end score, we are going to have one more text, which is going to be called best score. And for now, it's going to have new best. Let's change the font, and its position is going to be from the bottom negative 64, and its size, it's going to be 1080 by 256. Let's position at the center, change the size to 128, and the color, let's have it 384112. Hmm, I think green should be, yeah, green should be fine. So this is going to be our default color. Maybe let's just have it at a white, brighter white. So this is going to be our end score, what it's going to show, as it will show our best score. Now after that, we are going to have a couple of buttons. The first, and everything's going to be an image. So the first one, which is going to be at the center, is going to be called for the restart of the game, and its size is going to be 384 by 384, and its position is going to be negative 384. And let's have the button to be our return. So this is our return button, and it's also going to have a button component attached to it, which transition it's going to be none. And after that, we are going to have two more buttons. The first one is just the share button, so we are not going to add the share, but uh, for it to not look too bad, I just added it, and its size is going to be 256 by 256. And let's add our share. Now similarly, we'll add our next button, which is going to be for our sound. So it's again going to do the same thing, toggle the sound. And for the image, we'll use our on sound image. And again, still I think they are too large. 256. Let's have it just as 256. And finally, we are going to have our go to menu button, which is going to have the grid. X is going to be 0, and again it's going to be multiplied by 2. And that are all of our buttons, and as you can see, all of the buttons are self-explanatory. The toggle which you already created, the restart, and the both are just going to change the scenes. So this was just for our button. Now let's first create our player, and we'll hide our end panel. So this is going to be our default how the screen is going to look. Now let's create a UI, and not a UI, a 2D object and a sprite and a square, and we'll call it bar, which is going to be positioned at the top. And instead of square, we'll use our default pixel, and its position is going to be 0 and 7. Now if we change this mode to sliced and increase its size to 20, multiply 0.4, so as you can see it's pretty much large. And we'll set its color to be the white color, which is our default color, and it also needs to have a box collider 2D attached to it, which is again going to have a size of 20 and 0.4. And after that, because this size is too small for the project settings, let's change the time, the fixed time step to 0.005, so it will not miss anything. Or if you want, you can rescale the whole size, so there are not much problems. Now after this bar, we'll have a tag of respawn because our player collides with it. We are literally going to like end the game. And that's our simple bar. And now let's create our game manager, which is going to just have our game manager script and nothing else. Now let's start creating our template for the player. So let's create an empty first, and we'll call it player, and it's going to be positioned at the top. Let's reset its transform. So the first thing we are going to add is a sprite renderer. What do we need to add? Yeah, it's the sprite renderer component. So SPRITERE, and yeah, there is the sprite renderer component. Instead of simple, we'll set it to sliced. And for the image, we'll use our circle image. and its position is going to be at -7.5, and its size is going to be 0.75 by 0.75, and the color, so this is going to be at the top center. Hmm, not black, white. Two and a center of 0.5. So how did it look? So let's first add a circle collider 2D, which is going to automatically have the correct size, and rigid body 2D because we need to detect collisions on it. And let's set the gravity scale to 0, and it should be fine. Now, after having our circle collider and rigid body 2D, we are going to create a new script for our player, and it needs to be inside our scripts folder. And one more new script for our obstacle. So this is our player. As you can see, it's just a default circle. Now let's add, first let's create an empty, and we'll call it BG. And again, this is going to have a sprite renderer component attached to it, which is going to have a sprite of circle. And the ordering layer, it's going to be -1, and its size, it's going to be larger, and what its color is going to have a transparency of 25, so we are able to see it as like the field or whatever you want to call it. After this BG, we are going to have one more which is going to be centered, but this one is going to be on top of it, and its size is going to be 0.5 by 0.5. 0.75 and 0.5. The color is going to be 2161. Uh, 2163119. So this one's color is going to be black, and I think the outer one it's going to be pure white. I mean, like we can change the colors, but it's going to be similar. So this is going to be our player. Now inside our player, again we are going to have one more. Let's just call it directions, and inside our directions, let's duplicate our center, and let's rename this to 1. All of them are just going to be default circle 010, and the ordering layer, whatever you like, size 0.24, 0.24, and our color, it's going to be white. And let's duplicate 1, rename it to 2, change the size to 0.2, move it at 1.5, and finally there's going to be our third one, which is going to be positioned at 2, and its size is going to be 0.16. So as you can see, it will be like showing the direction in which it is facing. So this is just going to be default template for our player, and finally it's going to have a player script attached. And now let's create our obstacle. So let's create an empty, and we'll rename that as obstacle. Let's reset its transform, and we'll attach a sprite renderer component, which is going to have our circle. So I'm just using the default circle and the 9 sliced. It would be better if you just use your own sprites, or maybe don't know what problems it will get, but it would be better if you use your own sprites. Let's set its size is to be 0.8 by 0.8. Order in layer, it's going to be on top of whatever that is in the background. It's going to have a circle collider 2D component tag of finish because we are finishing the current turn, and set to a trigger, no need for any layers, and it's going to have the obstacle script attached. So this is just going to be a default obstacle, and it's at 0th position. Let's add it as a prefab, and we'll need a animator for our score. So let's create an add an animator component, and we'll create an animator for our score, and we'll start with AC, and it's going to be score. Let's delete this obstacle from here, and we'll attach that animator to our score. Now if you open up our animator and also open up our animation window, which currently see it right here. So if we click on our score animation and hit create, and we'll rename this as am score under slash idle, and let's set the sample size to 30, so we don't need it to have anything else more, and speed and everything is fine. So if we hit play, nothing is happening. But now let's create one more animation, and we'll call it click. There's just one animation, so you can call whatever you like. And now let's add a property for the scale. So we added the property for the rect transform. Click. So there's the property for the scale. Now let's decrease its time to almost like 100 milliseconds or a little bit more. And what we are going to do is just change the scale from 0.8 to 1. So as you can see, if we hit play, it is showing like this. And let's set it to 0.75 and 1. Now inside our animator, it needs to play only once, so loop time is going to be off. And if we click our score and go inside our game and play our scale, so as you can see, it is changing. So in the editor, it always loops around, so when we play from our game, it should only play once. So that was just for animator. Close animation window, and uh, our obstacle also had the obstacle. Yeah, our obstacle is done. Now there's one more thing we need to add, which is going to be explosion. And first one is going to be our green, which is going to have a particle system attached. Now let's set up its parameter first. So duration is going to be 1.6. For now, we'll set the looping to true. And after that, start lifetime, we'll set random between two constants, which is going to be 0.8 to 1.6. And start speed, we are also going to have the random between two constants, 5 to 2.5. Start size, we'll directly set it as 0.2. Mm, Again, it's going to be a random between two constants, which is just going to be 0.1 to 0.4. So as you can see, our particles are looking a little bit good right now. And there is not going to be any rotation, so this one is the green, so we'll set the color to green. And after that, let's change the shape from a cone to a circle, and sphere, circle, and radius, I mean, doesn't matter whatever it is, but what we need to do is change the render mode from billboard to have a material, so it shows up our default sprite material. And in our texture sheet animation, instead of mode grid, we'll add our default knob or circle, whatever sprite you want to have. So let's add our circle sprite. So it's just going to show all of our particles. So the finally only thing we need to change is our emission. So let's set it to 0. Now let's add a burst at 0. As you can see, it is bursting. And the count, which is going to be random between two constants, and it's going to be from uh, 10 to 20 particles. And let's increase the number of cycles to like around 5, and cycles to 5, and the interval 0.016. So as you can see, it's just going to like flow along. So this is just going to be our default particle whenever we hit a point or whenever the player dies. Now let's save this as a prefab, and for the red one, the only thing we need to do is let's duplicate this explosion green, rename this as explosion red, and we could make a prefab variant, but already the project size is much lower, so it doesn't matter. We'll have it as red. And now if we add, no, we change the different one. So if we go inside our explosion red, change the color to red, we should be able to have it shown as a red. So this is going to be a red animation, and both of them are currently looping right now. So if we set the loop to false, and they will just burst once. So this were just the basic prefabs. We have the colors, all the resources, and everything is perfectly set up. So the final thing we need to do is add the movement to the player, have the player move towards the goal, and at the start we need to spawn our goal, which is our obstacle. You can call it whatever you like. And update the point and dynamically. So it's just going to be simpler as we create it step by step. So let's start creating it. Mm, yeah, should be finished in around half to 1 hour. So first things first, let's go inside our game manager and let's set up our presets first. So it's going to have using TM Pro, uh, using UI, and we'll also need to use the scene management, which is going to be Unity Engine.scene management. And let's create a public static game manager instance, which is going to have a grid and private set. And inside the awake, we'll just directly set instance to this. And after that, let's create a serialized field, which is going to be text for our score text. our end score text, and our best score text, and private integer for the score. Serialize field. Did I change to Visual Studio? No, almost. So we just added the using Unity Engine.ui, TM Pro scene management, and all this stuff. Now, after we are inside our serialized field, what we are going to add is our score animator, which is going to be an animator, and we'll call it score animator. And after that, private animation clip, score clip, serialized field, private game object, or we can directly get the obstacle, and we'll call it target prefab. Serialized field, private float, max spawn offset. Don't forget to add the underscore. And after that, serialized field, private vector 3, start pose, which is going to be starting position of our obstacle. So we'll call it start target pose. And after that, we'll for our UI, private image, and we'll call it sound image, and a serialized field, private sprite, and which is going to be our active sound sprite and our inactive sound sprite. So I just created the variables first, as I already done it before, and we'll start adding all of our functions. So what's going to happen inside our start? Let's first set the AudioManager dot instance dot add button sounds. After that, we'll set the score to 0, and we'll set the score text dot text to be score dot toString, and we don't have much, but we need to set the score animator dot play, and we are going to play score clip at the -1 layer, which is going to be the first, and we need to pass the name. And what we are going to do is spawn an obstacle, private void spawn obstacle, and we'll call the spawn obstacle function. And inside our spawn obstacle, let's first create an obstacle. Temp is going to be instantiate our temporary obstacle or our target prefab, and after that, let's create temporary position, which is going to be our start target pose, and our start target pose dot x is going to be random dot range from negative max spawn offset to positive max spawn offset, and we'll set our temp dot not temp temp dot game object. I think we don't need to set it. We just need to set temp dot move to pause. I will need to create it. So we need to have it move at that position. And now let's create the rest of the functions. So first function we will create is go to main menu, and what we are just going to do is scene manager dot load scene constants dot data dot main menu scene. Let's copy this main menu and instead of main menu we'll pass the gameplay, and this one is going to be for our load game. And after that we have our toggle sound function, which will directly copy from our main menu manager. Both are simple. And after toggling the sound, we are going to have our update score function. And inside our update score function, first we'll increase the score. After that, our score text will update it. Score text.text is going to be score.toString, and we'll play our animation, which should be, and after playing our animation we need to spawn one more obstacle. So that was our update score and finally our end game. So what's going to happen inside our end game? The first thing is going to be the end panel. I think we forgot to create the end panel. After the start target pose, serialized field, private game object, and this one is going to be for our end panel. So it's going to be end panel dot set active to true, and inside our start we need to set the end panel dot set active to false. So first we'll show the end panel, and after showing we'll change the end score text, and beyond that text we need to show our sound. So let's copy our sound, and we don't need to change this, and we don't need to get set it up. We are just getting it. And after that let's get the high score, and similarly it's going to get it from the player prefs constants dot data dot high score, and player prefs dot get int constants dot data dot high score, as it's going to be 0, and here instead of get int it's going to be get key. So after we get our high score, we'll check if our current score is greater than high score, else. So if it is greater, we'll set the score to be the high score, and not score to be the high score to be our score. Player prefs dot set int constants dot data dot high score to our high score, and our end score text, which is going to be best score text dot text. It's just going to call new best. And similarly, if it is not, then we'll just set the best score text dot text is going to be best plus our high score dot toString. So this will update the score, and that should be it for our game manager. Now let's go inside the obstacle because we need to set it up first. And inside our obstacle, that's just going to be a couple of parameters and a simple function which we are going to use to move our current player or our current obstacle. So inside our obstacle, game manager not needed, both of them. Main menu manager, constants, audio manager, yeah. So let's create a serialized field, and this one is going to be a private vector 3. and it's going to be start pose left and start pause right, and serialize field private float move time. And inside our start, what we are going to do is transform dot position is equals to random dot range goes from 0 to 1, and we'll check if it is greater than 5, then we'll position it left, else we'll position at the right. So this is going to be our starting position, and we'll export a method which is going to be move to pause, or we could just have it as an enumerator move to pause, and it's going to have vector 3, and we'll call it target pause. And let's first get time elapsed is equals to 0f, and after that, while our time elapsed is less than move time, will yield return null new wait for seconds, and we'll wait for time dot fixed delta time amount of seconds. And at the end, our transform dot position is going to be our target position. Now let's set it up. So time elapsed per is equals to time dot fixed delta time, and transform dot position is equals to v3 dot move towards, and we are going to move from transform dot position to our target position in the move time, or whatever you want the speed to be. So it will automatically set up our speed. You can have it 1 hour move time or whatever you like. So this is going to be function we are going to call from our game manager, and it's going to be called from our spawn obstacle. And what we are going to do is we'll start our coroutine temp dot. It's better to export a method. So temp dot and move to pause, and we'll pass our temporary position. Now let's go inside our obstacle, and let's add an I, and let's pass the public void move to pause and v3 target pause. And this one doesn't need to be public, let's have it private. And what we are going to do is start coroutine. There may be another method of how do you do, but it would be better if it is inside our obstacle. So this is going to be our obstacle. Our audio manager is also set up. Now let's start coding our player. So our player is going to have multiple things. So the first is when it rotates, then when it moves towards our target, and then when it returns back. So let's first create all of our variables. So first one is going to be a serialized field private game object, which is going to be our bg object. When we are moving, we don't want to show our background. Then our direction object, which yeah, we'll need it. After that, our green explosion prefab and our red explosion prefab. And let's create a private transform, and we'll call it direction transform. So we'll get the direction from the direction transform. It also needs to be hidden. Private bool has game started, and after that private bool can rotate serialized field private float, which is going to be max offset, and time for half cycle for our rotation, and finally initial offset. So currently it was like at above, which is 90 degree. It should be on the x-axis. So what I was talking about is our this current direction, which is 90 degree. The transform sets up the direction from respect to the positive x-axis. So current offset is 90. So whenever you want to get the direction, we'll need to subtract 90 from it. So that was the initial offset. And after that, we are going to have private bool can shoot, then private float shoot counter, and shoot counter speed. Mm, don't know what we are going to use for that. Private bool can move, and when we are moving, we are going to have a serialized field private float and the move speed and the start pause y. So if we go below our start position, we will see like it's just going to be reference to check our start position. And finally move direction where we need to move, and our serialized field private audio clip, and it's going to be our move clip, then our loose clip, and our win clip. So win is just individual points, and after that private bool can score. So the can score I added because sometimes the player has scored for the current obstacle and the next obstacle is going to move, so it has not moved, and whenever it collide, like it was always adding new obstacles, so its speed was a little bit higher. So I fixed it up later, but it was not like good to have it. You can call it as a bug. So direction transform uh dot rotation, and okay, direction transform is going to be direction object dot transform, and after that direction transform dot rotation is going to be quaternion dot Euler or 000, and inside the start function that set up all the parameters has game started is equals to false, can rotate is going to be true. We are not going to rotate, but is going to rotate. Can shoot is also going to be true. Can move is also going to be false because we are not going to move. And for our can shoot, our default shoot counter is going to be 0.5f, and our shoot counter speed, it's going to be 1 divided by time for half cycle. So we'll multiply it with the speed. So currently it is only 1 second, so it doesn't matter. And when we are moving, our current move direction is going to be 0. And after that, can score is going to be false. So we can only score whenever we are moving. So let's first create the update function. So first thing we need to check if we can shoot, and if we are clicking the mouse button, so input dot get mouse button down of 0. So at start our can shoot is going to true, then we'll call our shoot function, which we are going to create it below. So what shoot is going to do is first it will play the sound. So AudioManager dot instance dot play sound, and we'll pass our move clip. And after that, can rotate is going to be false. We'll stop rotating. Has game started is going to be true. So when we first shoot, the game going to be start. Can shoot is going to be false. We don't want to shoot again. The moving is going to be start. Can move is going to be true, and our can score is going to be true. So if we hit our obstacle, we are going to get the score. Now let's first get our angles. So we'll multiply the max offset, and we will do our shoot counter minus 0.5f, and finally we'll get the initial offset. So if it is 0.5, and I think we'll need to multiply it by 2f again. So if our shoot counter is 0.5f, our initial offset it's going to be 90, so it is fine. And our move direction is going to be new vector 3, and for the x we are going to pass mathf dot cos, and what we need to pass the cos of angle which we first created, multiply by mathf dot, it was in degree, so we'll transform it to radian, and after the cos we'll do the sine for the y position, and for the z it's going to be 0. So this is going to be our move direction, and by default it's going to be normalized, but let's just normalize that. Yeah, let's have it normalized. And after that we'll don't show the direction object, so direction object dot set active to false, and our background object dot set active to false. And now inside our fixed update, the first thing we are going to check if our game has started. If the game has not started, then we'll return. Else we'll check if we can rotate. So if we can rotate, we'll increase the shoot counter, multiply by time dot fixed delta time into shoot counter speed, and if our shoot counter is greater than 1 or our shoot counter is less than 0, that should be an F, then we'll multiply the shoot counter speed by negative 1f, so it will change the direction. And finally we'll set the angle, which is going to be max offset multiplied by a shoot counter minus 0.5f, and finally we'll multiply by 2. So I think we'll also need to multiply the 2 here. So it goes towards the max whenever it reaches 0.5 and subtracts, yeah. So this is going to be our angle, and finally direction transform dot rotation, and we'll pass our angle which we okay, we can directly, there's no need to do, we can just use quaternion dot Euler. So, and here we'll do, yeah, we should have also done that before. Nah, this was reverse conversion, so here we'll pass the angle. So it will automatically convert to rotation, and this direction we are getting as a vector. So that will happen inside rotate, and if we can move, then let's first get the target position, which is going to be transform dot position plus move direction, and our transform dot position is going to be v3 dot move towards, and we are going to move from transform dot position to target position and move speed multiplied, yeah, directly move speed. Won't need time dot fixed delta time. And if our transform dot position dot y is less than start pose y, then we'll set can move to false, can rotate to true, and can shoot to true. And finally, we'll show our direction object dot set active true, and also our background object dot set active to true. So it will show both our backgrounds, and let's create our temporary position first, and we'll call it transform where it's transform dot position, and our temporary position dot y, it's going to be start pose y, and transform dot position is going to be temporary position. So that was for the move, and we have the shoot. Now the final thing that's remaining is our on trigger enter 2D functions. So on yeah, we are still inside the update. So on trigger enter 2D, the first one is collision dot compare tag, and we'll get the tag from the constants dot data dot, not constants dot data, tags dot depth. So the game is finished. Then we'll first play the sound. So AudioManager dot instance dot play sound, and we are going to play our loose clip sound, and we'll first destroy our collision dot game object, and we'll spawn instantiate a red explosion prefab at the transform dot position at quaternion dot identity, and after that we'll invoke GameManager dot instance. So let's just directly call it GameManager dot instance dot endgame, and after that we'll destroy our game object and we'll directly return. And similarly, let's copy this whole line again. It's going to be similar, but here instead of death, uh, it should be goal, and we'll play our win clip. Destroy, we are going to destroy the collision.game object, and before that we need to check. If we cannot score, then we'll directly return. uh Instead of red, we'll spawn the green, and instead of endgame, we'll call the update score event, and we'll multiply the move direction by -1, so it moves in the opposite direction. So that should be it, and that was it for the scripting of our player. We don't need the generic ones. Now let's go inside Unity and let's wire everything up. So let's first wire for our game manager, which needs to have the score text, the end score text, the best score text, our score animator, our score clip, which should be inside our prefabs, and our score idle and score click, and our target prefab, which is our obstacle max spawn offset, which is going to be, let's have it around here, and we'll have it 5 point, not 5.95, 4.8 or 4.9. So it's going to be 4.9. Target position is going to be 0 and 7. Yeah, instead of 6, let's I think game, yeah, everything is fine, but instead of 7, let's have it 6. So the target position is going to have 0, 6 and 0. Let's add our end panel, our sound image, and both of our sprites which are inside our resources. So which is the audio on for the active and inactive for the audio off. Now let's add inside our player, which is going to your background, our direction, our two explosions which are inside our prefabs. So first one's the green, second one's the red. Max offset, here we are talking about angles, so which is 45 degrees. Time for half cycle is 1. Initial offset is -90 degrees, and move speed will start as 10. Start position is -7.5. And let's add our update, which is a move. Then our this one is going to move. Update is going to be inside our win, and lose is going to be inside our lose. Now for our obstacles, prefab obstacle, we need to also set our start pose left. So uh, it's going to be at -4.8, so we'll position at -7, and this one is going to be at +7. We are going to have the move time 0. So now if we play our scene, so let's see if there are any errors. Let's go inside main menu and let's start playing our game. Okay, so it is moving, the score is getting updated. Only thing is it's too much speedy, so there is a problem with the speed. So we'll go inside gameplay and let's set up the player. Let's see how the speed is, and we'll fix errors. So it is moving back and forth. There's a problem. We can see animations. Last was 4, and the only things that left is have all of our added the function. So let's add our restart, which is have reload game, share, red sound is going to be toggle sound. Go to menu, have go to main menu, and let's set up our parameters for our player speed, which is going the first speed that can go. And for our obstacle, the move time, yeah, it is now. Let's go inside our main menu scene, and this time we'll turn on the sounds, and that should be it. So, and play the sound. Okay, so still it's speedy. So let's go inside our gameplay for player, and let's set the move speed to like 5. Let's play the game again. So the best was already stored before. So the speed is so much higher. I think I'll need to change the move speed. Mm, 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 mm. Or maybe I mean, the game is working perfectly fine, so there is not much problem. But instead of move towards move speed multiply by time dot fix the time. Yeah, let's just add the fixed delta time for the player movement. Will be fine. So I just added the delta time to the player movement, and let's go gameplay, and let's have it back our player speed to 10, and let's go from main menu and let's hit play. Yeah, so now it is working. We could have it a little bit faster. Let's turn on the sound and let's play the game. And let's change the value directly, and let's see how it goes. So for the player, currently it has 10. Let's set it to 20. So 20 looks good, and that should be it for the end of the game. So you could also add different variations to our obstacle movement, like it may rotate, moves around the whole screen, changes the color, have different power-ups, or change the color of the disc, and there could be much more variations. And that was it for this video, and the link to this project will be also uh, down below. And if you did like the video, do like and subscribe to the channel, and if you really like the video, then do comment below. It would help for the YouTube algorithm. And we'll see you guys in the next video.